Data analysis is going to be a breeze, so follow along with Module 4 to learn how to manage background, signal burnout, or saturation in set linear dynamic range. Ready? Let's get started. High background appears as bright area along the length of the capillary and can make it difficult to identify and quantify peaks of interest. By including the proper controls when setting up the assay, the source of the background can be identified. Run a no primary antibody control, substituting antibody diluent, to determine to what extent the background is contributed by the primary antibody. Conversely, a no lysate control substituting lysis buffer can be used to determine the amount of background contributed by the sample. To decrease the assay background, it may be necessary to decrease the concentration of the lysate or antibody, or to decrease the antibody incubation time. The use of a purified primary antibody, or one that has been centrifuged briefly to remove particles, may also help to decrease background. Abundant proteins and/or high-affinity primary antibodies can result in a large quantity of secondary antibody bound to a specific region of the capillary. The high signal often leads to rapid consumption of the chemiluminescent substrate, causing the signal to burn out. When looking at the capillary view, a very dark spot surrounded by bright areas is suggestive of burnout. Another indication of burnout can be observed in the graph view as a large dip below the baseline signal. In a given sample antibody combination, burnout may occur only in later exposures, so it is a good idea to check the earlier exposures for peaks that do not split or dip below the baseline. To decrease the signal and avoid burnout in subsequent assays, it may be necessary to further dilute samples. Another way to recognize burnout is looking at the chemiluminescent signal for a peak at different exposures. If the signal intensity begins to decrease as you increase exposure time, this would be an indication of signal burnout. To maximize Wes's ability to quantifiably detect proteins of interest, it is important to verify that samples are within the linear range of the assay. This ensures that changes in peak area are directly proportional to changes in the amount of target protein in the sample. As the lysate concentration is doubled, peak area should also double. Lysate should be titrated to determine the limit of detection at lower sample concentrations and the point of signal saturation at higher sample concentrations in order to define the linear range of the assay. Optimizing antibody concentration for a simple Western size assay will help to maximize the linear dynamic range of the sample. Antibodies should be titrated such to find the dilution at which the signal is saturated so that signal changes are only due to changes in the amount of protein present. Depending on the antibody, there may be cases in which using a higher concentration of antibody isn't preferred because the background of the assay increases at a faster rate than the signal, so it is important to monitor background signal in both lysate and antibody titrations. And that's it. Didn't we say data analysis with Compass was going to be a breeze?